pi equals to, this looks similar to the one we did in class, but it's not the same, because we worked with cosecant in class. Y equals to negative 2 secant, and then parentheses x plus pi over 4. Okay? What's the first thing when we look at our reciprocal identities, or our graphs? In this case, what are we looking at? Well, what do we want to look at first?
What is the reciprocal?
Right. Okay, the reciprocal of secant is what? Cosine, right. So, y equals to a negative, and we'll use negative cosine. Since this is a negative, we know that this negative is going to do what for us?
Flip it across the x-axis.
Right, that's right. Reflect about our x-axis. All right, good. And it's going to be an amplitude of 2, right? But we're just looking at, we'll reflect it about the x-axis, right? Which means it starts down here at negative 1 and comes up and down, right? And we also know that when cosine reaches 0, the reciprocal is going to be 1 over 0. So therefore we need a what? Asymptote, right? Wherever cosine hits 0. Because that's where secant hits 1 over 0. Okay, so that means secant is going to match up with cosine where it peaks positively or negatively. And so we're only looking at one period here. But we know that indefinitely secant flips back up and down forever, right? But we're only looking at one period. Okay, and so we know that this is 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we know that it reflects about the x-axis, and the 2, we know that's our amplitude. And what's our k? K is 1, right? Therefore our period is going to be 2 pi over 1, right? Okay? And our, what's happening here? This is going to shift which way? To the left. Good. By pi over 4. So that means we need to subtract, right? Eventually. Okay? Alright, so here's 0. So we know our k is 1. Here's 0. Pi over 2k, pi over k, 3 pi over 2k, and 2 pi over k. And we know that k is 1, so none of these change, right? Pi over 2 and 2 pi. Okay, now we're going to, we said subtract, right? Pi over 4 minus pi over 4. So we need a common denominator, right? And so we get 2 pi over 4 minus pi over 4. So we get pi over 4, right? So here we are shifting, we have to subtract. So now, actually we need to do this one here at 0 too, right? Yeah, so that'll just be negative pi over 4. So we're starting here at negative pi over 4. And we already said that we're reflecting about the x-axis, right? And so it's going to start down here somewhere at negative 2, and it's going to come up, right? We need, so we've got negative pi over 4, and then here it's going to go through the x-axis at pi over 4. since cosine is going to go through there at pi over 4, that means we need what there? An asymptote, right, at pi over 4. Okay, and then here we got pi minus pi over 4. So we know that so far our graph is doing this. Alright, and so it's going to come up here. But we need to know where it peaks out at now, right? So we take pi, and we're subtracting pi over 4 from that, so that'd be 4 over 4, and we get what? 4 pi minus pi? 3 pi over 4. So now here it peaks out at 3 pi over 4. And now instead of coming back down here at 3 pi over 2, we've got to subtract pi over 4 from that, right? So we need a common denominator. So that'll be 2 times 3 is 6 pi over 4 minus, yeah. Alright, good. 5 pi over 4. Okay, so our other asymptote is here at 5 pi over 4. And we're going to finish up at, subtract 2 pi minus pi over 4, right? You need a common denominator. So we multiply 4 over 4 here. And we get 8 pi over 4 minus pi over 4. And we get what? 7 pi over 4. Okay, so that means from here, we're going downward like that. Okay? Get a little bit darker. Okay, so once you draw your secant, you can even, if you want to, erase the cosine curve, and then there we have our secant. Okay.